Hi, welcome back to LeetCode. So today I'm going to discuss LeetCode problem 1367, linked list in binary tree. Okay, so given a binary tree root and a linked list with head as the first node, return true if all the elements in the linked list starting from the head correspond to some downward path connected in the binary tree, otherwise return false. Starts as some node and goes downwards. Like for this example one, this is actually the binary tree, and this is actually the linked list is 4 to 8. Now I have to find out that in this whole tree is there any downward or any path or valid path that actually contain 4 to 3 sequence, or have to be the same. Like here actually you can check 4 2 then 1, so this is actually not valid, right? You can now here is 4 2 8 4 then 2 then 8, sequence is also correct, so this actually are valid, so that's why I have to return true. Suppose any other example, like our trees look like 1 2 3 4 5 6, then again 3, again 4, again 5. Okay, so I have to find out is there any valid path, downward path, who actually contain 3 4 and 5. This actually our linked list. Okay, so I have to find out the true or false. Like first of all you check what actually is 3 starting from 1 starting from here, another is 3 is from here. So I will actually just start from here actually, right? So what I will have to check first, this actually the one path, is this valid? No, 3 4 actually present but 5 is not actually complete, so this is not valid. Now this actually 3 3, this is also not valid because 3 after that each has to be 4. Next path is like 3 4 5, this is actually valid, yes, 3 then 4 then 5, so this is actually valid, so that's why I have to return true. If suppose the linked list contains 6 also, is there any path 6 containing 3 4 5 6? No, because this actually only path 3 4 5, but 6 is not present on that path. Right, so that I have to return false. Got it? So what I actually doing, how I actually doing actually? So first of all I have to iterate the actually tree first. Okay, so I'll check that if the current node of the tree is the starting of the head linked list, head of the linked list value, it is same, then actually this is a possibility that there may be a valid path, downward path, right? Like here actually whenever you see 3 here actually, but after iterating first 1 then 2 then this 5 then 6, suppose we come here to 3, not this node, then what I will do, I'll check, okay, these 3 and these 3 are same, okay, so there may be a possibility to get a valid path, so I will just start a checking that is the valid path. So how actually, what is the valid path starting from this actually? One path is 3 4, this path, one path is 3 3, one path is 3 3 then 4, then 3 3 4 then 5. Alright, this is one possibility valid path starting from this node. So I'll check each one of the path, I have to check that this actually complete or not, this linked list is contained or not in this path. So that's why I have to go to the right also and the left also. Like it may happen that this may happen, like right 3 then 4 then this is also 4, then I have to go to suppose 5 here and this is 6, so that's why, and our linked list path is 3 4 5. So if I go to only this path 3 4 6 and I'm not check this 3 4 5, but this actually I will get the answer from this path actually, right? So I have to go to actually this path also and this path also. I do not know that which will be actually matched, so that's why whenever there is any branch I have to go to the both side, right? And suppose this may happen that suppose 3 4 5, then I got actually 7 suppose, and 7 actually present here actually, so that time whenever I go to this like 6, then I don't have to go to, suppose this is 8 also present, 8. So do I need to go to 8? No, because 6 in between there is, I need actually 5, but I got actually 6 here, so I don't go to the downward after that because there's a mismatch in between, so I don't go to down, so I will just break from here, that is this path actually follows, I don't get any match if I start from this node. then I am already going to the deep of this path hierarchy. So I will get to 5 already matched, then go to the next node 7. Okay, 7 already matched, then I have already completed the linked list. So this is actually true path. Got it? So just go to the code, it's really easy, right? So here actually we have taken a queue, okay, which is storing the current actually node, starting node, current starting node, because suppose this may happen, right? 1 2 3 and then again 4, then again 3. So if our linked list is 3 4 5, then I have to I have to check that can I start from this node and get a valid path or not. Can I go to starting from this node too, then can I get any valid path or not, this way, in this way, right? So that's why I have to iterate each node. So that I am taking a queue which will store the each starting node, right? So that's a queue. Initially I am inserting the root node into the queue, and I am iterating this while loop until the queue is not empty. Means I have not iterated till there is that n nodes present in the tree, binary tree, right? And it may happen that in between, before completing, suppose before coming to this this node 3, I got the match like 3 4 5, I got a match from this node path. So that time what I have to do, I don't have to go to the any other node. So that time I will break from here and return true, that yes, there is a match, right? So that way our queue is not empty till I have to iterate. So I will come to this line. What I'll do, I'll just what is the node point currently in the front of the queue. So what will root node, okay, root, and I'll pop from the queue. Now I'll check if the root node current node value that I can actually start from this node, right? So that time I have to do, I'll just check what is the current value, like current node value, and the linked list head value. Head value is the first node linked list node value from the linked list. If it is both the same, then there is a possibility that can be a valid path. So I'll call a function check path, or passing the head of the linked list and the current node pointer, binary tree node pointer, okay. And if it is any valid, if I get any valid path, that time I have to return true from here. I don't have to go to any other starting node. It may be possible not in this way. So if I get in false, that I have to go to the left also and the right also. There may be possible that we can get the starting node from here also, any side actually it's possible, right? So that's why I will check if there any left node present, then insert that left node into the queue. Similarly, for if there is a right node, then insert into the queue that right node, okay. And if there is no any valid path, I don't get any valid path, that time at the end, and I have also iterated all the node in the binary tree, that time at the end return false. Now there I call a check path function, right? That actually what actually it's checking that if I start from this current node, is there any valid path that actually contain that linked list value in sequential order. So I'll check, I will get the head pointer means the linked list and the current node pointer of the tree. I'll check if head is not null. Not null means what? It is actually true. If it is already null, then I'll check, okay, I have already reached the end of the linked list. That time I will return true. Means suppose I want to search 1 2 3, okay, and our linked list pointer already reached null. Null mean what? I have already reached the end of the linked list. That time I have already actually matched all the path 1 2 3. So that time I have to return true. Else what will happen? It may be possible that I have already reached the 1 2 3. So 1 2. Then our tree is already ending. So this will be null. This will now current node will point to the null. Right? That time what I will not get any node with value 3. Then no chance. So that time I will return false because I have already reached the end of the tree. Now what is the situation can arise? So 1 2, suppose 3 and 4 also. So I have already matched 1 2, then I am actually come to this 4. So and our linked list is 3, actually last value is 3. So I have to check this, what is the current node value and the linked list value, that have to be same. That's why head value, the linked list value and the current node value have to be same. And like I've already matched this. Now I go to the next node and the next value also, right? Again call this recursive function check path by passing the head next, the next node of the linked list, and the left node of the current tree node. Or means because there are possible that both left side and right side can contain the valid path. That's why I have to go to the actually left side or right side. I have already said. So that's why again I am calling or. If these have to be same, these have to be same, or I will go to the left path. I can get from the left path or a right path. So that's why I'm calling this head next with the left node and with the head next with the right node. If any one of this get true, this actually or, so if any one of this output is true, that time I will get the okay, this is I got a valid path. That time it will return actually ultimately true. Suppose the current node value is not true, actually not equal, that time I have to return false actually, because here actually you can check 1 2 4 and the 3 we are trying to search, this is not same. That time I will actually break this. I don't go to the down the hierarchy because I've already got a mismatch. So that time I will break here from this actually head value and the root value means 4 and the head value in the linked list value is 3. So this is not same. So this will break. I don't have to go to the actually this part check path because this is already false and this is AND condition. So it will break from here. Right? Understood the logic, right? And if you still any doubt, you can actually comment. Actually, I will actually really happy to explain that your doubt actually. Okay. Now, what is time loss of this? Like you can actually check that this while loop is running. How many times actually it can actually run actually? If there is suppose tree content n nodes and the linked list content m nodes. Okay, n and m. So how many times actually this while loop can run actually? N times, because the there are n nodes. So I have already explained that why actually this while loop is running, because it may possible that I have to find out the starting node of the valid path. So that's why I have to go to the each node that this is valid or not. That okay. So each node I have to iterate. So that's why this time velocity can be big of n. Now inside that I am calling this check path function. What actually is checking actually that any path actually like same like valid or not. Valid or not means same or not, any content same or not. So that time I have to iterate at least m times. M or n, what is the length of that particular time? So suppose m is the length of the linked list, right? So I have to iterate at least m times if I have to match that. So that's why for each n times I am calling this function m, that is iterating m times. So the time velocity will be n cross m. Got it? Time complexity. Any space complexity is present? No, we are not yeah, q is actually containing, but this actually the time velocity can space complexity can go to big of n because n nodes are present. So I can go up to n nodes in the q to iterate to start from that, right? So if you like the video, please like the actually video on the okay. And if you still any doubt, any suggestion, any feedback, you can actually comment on that. I will be happy to help that. Okay. Thank you.